Hey everyone, welcome to day 22, Math 133. We are going to be talking about the cumulative review number 6, and it is on page 591 in your course pack, 591. We just finished chapter 9, the cumulative review worksheet number 6. It covers chapters 1 through 9. Okay. So the cumulative reviews are a really good way to study for the final exam. Final exam is going to cover chapters 1 through 11. So uh, so it's covering just everything, right? So we skipped a couple of the cumulative reviews. We did number 3 back in February. But we skipped cumulative review number 4 and number 5. So those ones might actually be good ones if you are studying for the final exam. We're not going to do those ones, so they're blank. So if you look through those, because when you're doing the chapter 9 review, you know that everything is chapter 9, right? And chapter 9, all that information is on page 259 in your exam notes packet, right? But today we're gonna pretend that this is kind of more like the final exam where on test day you have the entire exam notes packet to look at, right? And this thing is huge. There's like 14 pages in the exam notes packet. So I don't want you to have to be like flipping through like, where is the formula for this, right? So um okay, so anyway, if you want to practice for the final, you can try out cumulative review 4 and 5. Today, though, cumulative review number 6, H591. Go through, give you some hints. Scatter plot shows the relationship between the U.S. state's average per person income and its food insecurity rate in the year 2021. What is the strength of this linear relation? Regression, interpretation, all this different stuff. So I'm going to ask you guys for help putting these hints together. Where do I find because there's a number line, right, that is going to help me tell what strength this relationship is. Where do I find that in my yellow exam notes packet? Raya says page 255. Yeah, page 255. That is all of the linear regression stuff. Okay. Okay. So that's where you'll find the number line for the strength. That's where you'll find the interpretation. There's a script for slope, right? What is the y-intercept? Remember that y-intercept is 0 comma something. Okay, it's a point on the graph, so you need the 0 as well. Explain why this does not make sense in the context of the situation. So there's 2 scripts for that on this page. There's when x is 0, y is expected to be this. Most of the time, though, the y-intercept makes no sense. So your script is impossible for blah, 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 right? And usually the reason why it's impossible is because x is 0 and x, can't be 0. So anyway, all right, so that's 591. Let's go on to page 592. All right, the following probability distribution is based on research of a random group of US adults. The random variable x equals the number of days they would x is the number of days they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. Explain why this is a valid probability model. So there's 2 parts to that. There's the sum of the probabilities. Probabilities is 1, right? So sum of the probabilities, that equals 1. Yep. And all of your probabilities are between 0 and 1. Yep, between 0 and 1. Okay. Um, so that's if you wanted to write it out. Uh, I'm lazy. Mathematicians are lazy. So if you want to write it in math, sigma, capital sigma is this. That's the symbol for sum of the probabilities is 1, and the probabilities are all between 0 and 1. So that takes a lot less to write than the whole English, but um, you know, either one is fine. Okay. I like the math one, but that's just because I'm a mathematician. If you write all this, uh, like most people like wouldn't understand any of this, right? Like if you were to text this to someone, like they're gonna be like, I have no clue what that is, right? So here's the English. Although don't text this, they're not gonna understand what this is either. So don't text this to someone. All right, anyway. B, if a single random adult is selected, what is the probability they would wait 4 or 5? When we see the word or, there were two ways we could look at it, depending on if it was disjoint or not. Where in my exam notes packet do I find information on probability formulas? So there was an or, not. There's a formula if it's not. Um, right, there's a bunch of formulas. One of them was like probability of at least one. That was the most complicated one. That was like two problems in one, right? Crystal says page 254. Yeah, at the bottom, probability rules. So if they are disjoint events, you just add them together. If they're not disjoint and you have an or, you add them together, but then you have to subtract where both events happen at the same time. You have to subtract the intersection, okay? Complement rule is if it's not something, and then the at least one is like a whole convoluted thing, right? At least one, you have to calculate the probability of not the event, and then plug that in here, 1 minus that, power of n, right? So that is all on page 254, okay? Um, okay. Uh, blah, blah, blah. Find the mean of the probability distribution, find the standard deviation of the probability distribution, and interpret the mean and the standard deviation. So, um, where in my exam notes packet do I find information on how to calculate mean and standard deviation? Right, so I'm doing this on test day. I don't want to be like, oh, shoot, I have to calculate standard deviation. I know we talked about that. Where is that? There were three methods, right? There were three methods that we talked about. So that's going to be the next question is which method is it? Um, so page 253 has the script, the give and take script. So we'll need that. But yeah, James and Crystal, you guys got it. Page 254. So this one's on 254. This one's also on 254 at the top. There are the three methods for calculating mean and standard deviation. So method one is data in a single column. Method two is a frequency distribution. Method three is a discrete probability distribution. Which method are we looking at here? Which method are we looking at on page 254 to calculate the mean and the standard deviation? So method one is if I have data in a single column, meaning I have the raw data. So I have two columns here. I have the number of days and the probabilities, okay? So it's not number one. Number two is if I have a frequency distribution. For that, I need counts, okay? I need midpoints, class midpoints, and then I need frequency counts, okay? Method three is a probability distribution, and that's what I have here, the following probability distribution. So this is method three, okay? So I'm going to do stat, calculators, custom. I have to type in my numbers, Stat calculator's custom. Okay. So, yeah, so on test day, like I don't want you to have to be like flipping through like, oh, where is this? So, on test day, you get to have your exam notes packet, all 14 pages. You also get to have an 8.5 by 11 piece of paper, front and back, two of them. And you also get to have your flow charts, right? There's a chapter 9, chapter 10, chapter 11 flow chart that you get to have. So on your 8.5 by 11 piece of paper, it might be good to have written out like just kind of a table of contents for your exam notes packet. So like what kind of things? So page 253, this is my Z scores, right? Z scores and the percentile script, right? Page 254, that was the three methods for mean and standard deviation, right? And then at the bottom of that was probability formulas. Yeah, prob formulas, right? Page 254, sorry, 255, that was all of our linear regression stuff, right? So that way when you're going through this and you're like, okay, this question is asking me to do binomial probability. Where is that? I know that we did that in StatCrunch. There was some buttons I had to click in StatCrunch for binomial probability. I don't remember where that is. You can look at this exam notes packet and be like, all right, where is binomial? Instead of having to flip through this whole thing. So it's on page 256. That's binomial probability, right? And the stats for that is stat calculators binomial, right? So anyway, uh, I think this is helpful because, that way on test day, you're not flipping through trying to find what page the formula is, right? Because there's a million formulas in here, right? It's great, but so you don't have to memorize anything, but you do have to know where to find it, right? Okay. All right, I'm gonna move on. Next page is page 593. A random sample of U.S. colleges and universities is taken, and their in-state tuition in dollars is analyzed, assuming central limit theorem conditions are met. Compute the standard error of the sample mean. So where in my exam notes packet do I find that standard error of the sample mean? So standard error, and then the symbol we use for sample mean is X bar. So this is the SEX bar formula. So any guesses where I can find this? 258. Let's see, 258 is critical Z values, critical T values. So I think so. 259 is confidence intervals for a single population. And they do have right here SEX bar, but there's not a formula for it. So you can kind of figure out the formula, but it might be a good idea to just write that formula on here. SEX bar is, so the margin of error is this crazy thing, which is this. So T alpha over 2 times standard error of the sample mean, which is S over root N. I know that the exam notes packet says you can't write on it. That's for some teachers. You can write on the exam notes packet. I don't mind. Okay. But even so, if you write this here, like on test day, you're gonna be like, I wrote it somewhere. Where am I gonna find it? So, all right. So that was on page 259, and that was confidence intervals. And our SCX bar formulas on there too. Okay. So yeah, or this might just be one that you just write on your 8.5 by 11 piece of paper. But anyway, so there it is. S over root N. And there's another formula for SEP hat, right? So you'll need that as well. So you'll want to write that out. Square root P hat Q hat over N. Okay. A Pew Research Center survey of 1,895 internet users found that 1,000 who have, there were 1,222 who agreed that online dating is a good way to meet people. Okay. Um, Describe the population. So the population is all something. Okay. All whatever, whatever. Okay. Sounds like some people are not in this 1,000 group. Um, Based on these data, compute the point estimate for the proportion who agree. Point estimate. Your point estimate is P hat or X bar, depending on whether you're doing probabilities or means. Okay. Pew Research Center wants to replicate the study. So they need to figure out how many people they must survey. Using the point estimate as a prior estimate, calculate the minimum sample size required to create a 99% confidence interval. The population proportion margin of error is this. So we need the formula. We need the substitution. And the result. Where is the formula for this, though? So 259 is confidence intervals. Um, Mike says 2,261. I know what you meant, Mike. 261, yeah. Um, Imagine we had that many pages in our course pack. Feels that way sometimes. Um, uh, yeah, so page 259 is confidence intervals, but we're not constructing a confidence interval here. They want to know how many, they want a sample size. So page 261 is sample size formulas, right? For how many. How many do you need? And there's a couple of them. This one, if you have a prior estimate, no prior estimate, if you're doing means. There's also two down here that we're going to talk about in chapter 11 when we talk about multiple populations, double populations. So all the sample size formulas on page 261. Okay. Um, all right, sounds good. Let's go to our last page here, page 594. Find the critical values for a 88.5% confidence interval for P. Show correctly. Okay, round to 4 decimal places. So what page do I find this? It's talking about confidence intervals, right? So page 259 is how to calculate the confidence interval. But we're not calculating confidence interval here. We're calculating the critical values. So we we could build the confidence interval, but we need P hat and Q hat and N and the critical value. All they're asking here is for us to calculate the critical value. So yeah, page 258. You guys got it. Page 258 is how you find critical values, critical Z values, critical T values, right? We talked about this stuff in chapter 7. So let's write that in our handy table of contents here. Page 258, critical values. Okay. And we've been doing this critical value stuff since chapter 7, chapter 8, chapter 9. So if you don't need this because you already remember stat calculator's normal and then click between, then you're good. But if you need that information, if you aren't sure what buttons to click, so page 258. All right. In 2014, there were roughly 500,000 electric vehicles on the road worldwide. You want to construct a confidence interval for the average miles per gallon equivalent these cars had in 2014. The table below shows the miles per gallon equivalent for 5 random cars. Okay. Um, so so an electric vehicle doesn't use any gas, right? But it does use energy, and energy still costs something. Like even if you're on solar energy requires like a factory to manufacture it, and it requires maybe some space. Like you might have to cut some you know, cut some things down so that you have space for your solar panels. Even like hydroelectric, like you have to put up a dam that can affect ecosystems. Uh, Wind power, right? Putting up wind power, a wind farm that can be damaging to birds. So there's still a cost, um, even for an electric vehicle, and that's what this is. It's looking at miles per gallon equivalent, right? Um, so how much, you're still hurting the, I mean, it's definitely better than gas, right? 100 miles per gallon equivalent, like that's way better than any gas car that exists, right? So anyway, that's what these are. That's what we're measuring here. Verify the conditions are met in order to construct a confidence interval. You need to make sure that it is random, independent, and normal, right? Based on these data, construct a 90% confidence interval. What page do I look at for that? What page do I go to? Because I'm going to need the formula. What page is my formula on? Formula, substitution. Yeah, you guys got it. Page 259. And our result. So Mike's jumping ahead on me. Page 259 is confidence intervals. Page 260 we haven't gotten to. It is confidence intervals, but it's for when you have two populations. So as you're going through, you don't need to make this table of contents right now, but as you're getting ready for test day, because there's some pages of the exam notes packet we haven't covered yet, but as you're getting ready for test day, I recommend writing this out just in your own words so that when you come across a question, you're like, where was that formula? You don't have to go search for it. So, yes, page 259. And that is all of our hints for today. Let's jump back to page 591 and let's do some math.